Okay. So now the actual value of node 6 and node 7, okay, so here it's like, so well, we have node 6 as dislike. Okay. We have node 6 as dislike, node 7 as like. So since the first observation is like, okay, the value of 6 is 0, value of 7 is 1. Okay. So now the error is, well, y hat. Now y hat is the output, that's your output for node 6, and this is the output for node 7. Okay. Now the error is the actual value minus the predicted value. Okay. Now what we can do is we can sum these two, and that will be our total error. Okay. Now there are other ways of computing error as well. Okay. We can compute error in terms of squared, sum of squares of error. You can have cross-validation error. So there are many options for computing error, and I want to keep it simple, so let's just use y minus y hat and take a sum of that. Okay, so that's our error, and this is a kind of a simplistic view. Okay, I'm just trying to show the kind of the type of adjustments that happen when you go through the neural network training computations. Okay, but when we run R, the error is actually computed as SSE, sum of squares of error. Okay, so that is square that, and make an average of the two. That's what actually is happening. Okay, now we have the error here, right? And we want to take that error backward. So we're going to take the error and go back. So to 3, okay, we're going to take these two errors and then make some adjustments to these coefficients. Okay, so there are, for this node, we have 2 weights and a bias. Okay, so that is the bias, and there are 2 weights. So we need to now make those adjustments. Okay. All right. Okay, so we have node 6. We have the old weights for node 6, which is that is our bias, and then the weights. Okay, so these are the current weights. Okay, now that we have an error, okay, okay, so I misspoke. So this is the error formula. I was thinking about it, and so this is wrong. Take that back. Okay, so this is the error formula. Okay, so this is one way of computing. Again, this is one way of computing error. The actual error that we're going to do in R is sum of squares of error. So this is more like entropy. So this will be like y hat times 1 minus y hat, okay, times y minus y hat. Okay. Now that's the error for node 6, and then that's for node 7. Okay, so Now, node 6 errors or that's the error in node 6. Now, the revised weights are given by this formula. So, new weights is you take the old weight, okay, and add to the old weight a part of the error. Okay, you don't add the entire error. Okay, so that is called the learning rate. Okay, the learning rate once again can be by default R will set your learning rate, or you can specify a learning rate yourself. Okay. So we will use learning rate of 0.5. Okay. So then you take the old weight and add. Okay, I'm going to have to. I'll make that absolute reference times the error. Okay, so that will give me the new weight. Okay. All right. Okay. And I do the same for 7. Okay, the current weights of 7 are these, okay, and the error for 7, okay, node 7 error is that. Okay, so and then I adjust the old weights by adding that portion of the error to it, and then we get the new weights after the first. This is your backward propagation for the first observation, just first step of the first iteration, and you're only half done. Okay, so now we have the new weights for 6 and 7. Now we have to go back one more and figure out the weights for 3, 4, and 5.